Secondary coolants are fluids used to transfer heat in refrigeration systems by acting as an intermediary between the primary refrigerant and the area or substance being cooled. Unlike primary refrigerants, which undergo phase changes to absorb and reject heat, secondary coolants remain in the same phase, typically liquid, while carrying heat away from the cooled space. In a refrigeration system using secondary coolants, the primary refrigerant absorbs heat from the secondary coolant in a heat exchanger. The secondary coolant, now cooled, is pumped through pipes or coils in the space or system that requires cooling. As the secondary coolant circulates, it absorbs heat from the environment or product being cooled and returns to the heat exchanger, where the cycle repeats. The indirect cooling provided by the secondary coolant allows the primary refrigerant to remain isolated, reducing the risk of leaks and contamination. This is especially advantageous when the primary refrigerant is toxic or flammable. There are, however, disadvantages of using secondary coolants. First, secondary coolants typically have lower heat transfer efficiency compared to primary refrigerants, meaning they will require more energy to achieve the same level of cooling. Second, the use of secondary coolants requires additional components like pumps and piping to circulate the coolant, which may increase the complexity and cost of the system. Third, even with additives such as glycol, secondary coolants must be carefully monitored to prevent freezing, which can cause system blockages or damage to heat exchangers.
You might wonder, why would someone choose to use a secondary coolant instead of just direct refrigerant cooling? And there's a few reasons one might choose to do that. One common reason, especially if the main refrigerant is ammonia, is by using the secondary coolant, we're able to limit the footprint of our hazardous material, being ammonia, to a smaller area, and then just take secondary coolant out to space where people might be working, or if it's some sort of space where people are congregating, it's safer. So that's one main reason why it happens. A second is that secondary coolants, while they do make the system less efficient, which is not a good thing, they are easy to work on because we're just dealing with a single phase of flow. It's always liquid. So we end up dealing with simpler types of systems and piping. Sometimes the secondary coolant piping can be PVC with water flowing through. So it kind of lowers the bar, the threshold of what's required to work on it. So that's an advantage as well.
There are many types of secondary coolants. Water is most commonly used as a secondary coolant due to its excellent heat transfer properties. However, because of its relatively high freezing point, it is often mixed with additives such as ethylene glycol or propylene glycol to prevent freezing and corrosion in low temperature applications. Ethylene glycol is toxic and therefore cannot be used in facilities that handle food or beverages. Water glycol mixtures are common in HVAC systems and other refrigeration applications. Brine solutions such as calcium chloride or sodium chloride are used in applications requiring low operating temperatures. These solutions have good thermal properties and can remain liquid at sub-zero temperatures, making them suitable for cold storage and ice rink cooling systems. Brine solutions are attractive because they are inexpensive, but carry the downside that they are corrosive and must be handled with care. Alcohols like methanol or ethanol can be used as secondary coolants, particularly in applications requiring temperatures below -40 degrees Fahrenheit. However, these solutions can be flammable and may require additional safety measures.